Welcome to my workshop. My name is Robert. I've received a few requests to elaborate on the clips that I've posted on the gear cutting attachment that I've made for my shaper, and I've finally got round to doing something about it. In this video, I'll describe each of the component parts of that attachment and I'll assemble them onto the shaper. I'll follow this up with a video on doing the calculations to cut the gears, to setting up the gear train and actually cut the gear. Finally, I did some modifications to enable the attachment to cut helical gears, and I'll describe them in a further video. Thanks for watching. Let's get started. This is my Elliott 10M shaper, which I've had for about 5 years. When I got it, it was in considerably worse state than it is now, but a full strip down revealed it was in good condition underneath all the grime and the rust. I used it mainly for cutting internal keyways and splines until I hit on the idea of how to cut gears. In order to cut gears on a shaper, you need to be able to do two things with the gear blank. You need to be able to rotate the gear blank in time with the side-to-side motion of the table, and you need a means of indexing. There's a technique where you suspend a wire between two pillars and you wrap that wire around a disc. The disc has the same pitch diameter as the gear blank you're going to cut. That achieves the rotation, but you then need a separate means of indexing. I have this universal dividing head, and I thought it would be a good idea to make use of this and see if I could adapt some technique to get this to achieve both of those things. The indexing is taken care of with the hand crank at the side on the indexing plate, and the rotation is achieved by attaching the differential indexing shaft at the back here through a gear train to the lead screw, which moves the table side to side. So the next problem is, how do we connect the rotation of this table feed shaft through to the back of the dividing head? Prior to making the gear cutting attachment for the shaper, I'd been making a vertical feed arrangement, copied as best I could from a drawing in the manual. This optional extra, fitted to very few of these machines, makes use of a reamed bore protected by this plug. The 3/4 inch bore is used to locate a stub shaft on which the ratchet and ratchet wheel assembly is fitted. The ratchet wheel drives a gear on this shaft, which can couple to a mating gear on either the horizontal lead screw shaft or on the vertical feed shaft. The spacing of the shaft centres here describes an equilateral triangle and is correct for a pair of 14 diametral pitch gears with a total tooth count of 54 teeth. I chose to put a 30 tooth gear on the ratchet wheel and a 24 tooth on either the vertical or horizontal feed shafts. Obviously, for the gear cutting jig, the 24 tooth gear is fitted to the horizontal shaft, and this gear provides the perfect position to tap off the drive of this shaft to go across to the back of the dividing head. Okay, so now let's disconnect this standard arrangement for the feed and work towards installing the vertical feed arrangement. We firstly disconnect this, what the manual terms as self-act arm. We then remove a little grub screw here in this locking collar, and now the ratchet arrangement comes away. We now take off this arm and we will install a slightly shorter one. Okay, So the next thing we need to do is to disassemble the ratchet arrangement so that we can get the ratchet housing. And for this, there's a small grub screw here which we can take out. And then this ring is a tight fit, so we shall just put a piece of aluminium tube on here, reach for a soft blow hammer and move it gently. So that now comes apart. We now have the ratchet, the ratchet pull. So the next part is this arrangement, which is a ratchet wheel attached to a 30 tooth 14 dp gear, and we're going to separate the gear off of this and fit the ratchet in there. This is a tight fit, hence we're at the press. There's a 1/4 grub screw that holds them together. Now we can place that under here. Get our little aluminium tube. Apart. The ratchet now simply assembles on here. When this gear goes back on, we can use the press, this time with the daisy wheel. To reassemble it, put the screw back in. So we now have the modified assembly. So now we fit the stub shaft. This stub shaft, it's just a simple shaft with a hole through the middle for oiling. This end is just a housing with a thrust bearing in it, and there's a spacing washer on the back, which was just used to get the right spacing there, to get the gears to match up. This goes into this hole here, nice smooth fit. There's a, looks like about 5/16 18 TPI thread in the back. Just give the thrust bearing a little bit of clearance. Make sure that rotates smoothly. Find a spanner and just nip that up. Next, the ratchet housing. This slides on here and the gears engage. Then we have another housing with another thrust bearing, which we put on here. And finally, a nut to lock it all together. The threads on this are a bit tight, but it does work. And finally, just make sure that, well, that obviously won't turn. We'll get a handle. Make sure that things rotate nicely. Doesn't need to be too tight. Grab an Allen key and nip the brass tipped grub screw up. Finally, the shorter arm can be screwed into place. Here we are, all assembled. Now the idea is, as the shaper feeds, the two gears will drive the lead screw and move the table, and at this point here we can then have another gear which can pick off this rotation and transmit that motion towards the dividing head. Now we come to the three assemblies that constitute the gear cutting attachment. This first piece mounts on the cross slide of the shaper. It has a 24 tooth 14 dp gear which picks up the drive off the lead screw of the table and transmits that rotation through a shaft. This has a 4-tooth spline on it. This enables this component, which has a 4-tooth spline on this long shaft, to travel as the table moves side to side and maintain the drive. On the end of this is a helical gear. This is 45 degrees and this one is 14 teeth. The 45 degrees on the helical gear enables the drive to be turned through 90 degrees onto this shaft. This shaft has an 11-tooth gear on the end, and on the far end here, this is where we install the gears which drive the dividing head differential shaft. The reason between these sort of peculiar numbers is that 14 over 11 is approximately 4 over pi. A factor of pi comes into the equations needed to calculate the ratio, and this is a crude attempt to try and remove some of these awkward numbers, because we'll be using integral numbers of teeth obviously on the gears to make up the ratio. So now let's install this component onto the shaper. This component bolts onto the shaper just here. It has two clamps, the bottom one being held with two screws, the top one with a screw and a pin. There wasn't room for the second screw on there, so we take that off, remove that part, slide that on here. There's a recess here. This is not standard. This is because when I got the shaper, this was crudely broken, and rather than leave it as a crude broken part, I tidied it up with an end mill. Get the gears in engagement and pull that one up. I'm looking down from the top to make sure that the gears are in alignment. The next thing is to shift the table out of the way so I can drop a square and attempt to make sure that this is actually as level as possible, or vertical as possible, otherwise the shaft that runs horizontally will bind. Okay. So now we'll wind the table to the left to get it out of the way. This next component here, I make use of the T-slots in the table to mount this. There's not an awful lot of room for everything here. This slides in the upper T-slot. And now we can feed everything back together. Line up the splines. Now you can see how this shaft works. Sliding through to maintain the drive and fouling on the handle, of course, as soon as it gets too far to the right. We now need a 17mm spanner. Tighten up this nut. There's no particular requirement for this assembly here to be orientated in any particular way. It just needs to be lightly snugged up. And it runs nice and smoothly. Now we can take the last assembly, slide it in here, engage the gears, this one is using the lower T-slot to mount on the table, and we just snug those two bolts up there. We don't want the engagement to be too tight. You need a little bit of backlash. The backlash doesn't matter because you only ever cut gears in one direction, so the backlash is always taken up. And now the whole mechanism is functional there. Okay, so the final part of this assembly is assembling the gear train between these points. So we'll put a spacer on here. For this section there are many combinations of spacers, gears that all need to be made, different shafts to go on the banjo. So this shaft steps down to a very thin diameter to make sure that I didn't have to use enormously large diameter bushings on the housing here. So I've got bushings to space it up to the bore of the gears. These are 3/4 bore. The key just needs to go down a little bit. So that one goes on there. secure that on with a knurled nut. Now we need to fit the banjo. Now for this part I have cheated and I have pre-assembled some gears on here. Except I haven't quite got the right spacing at the back. We need another spacer. That gear on it's carrying. And that now meshes up properly. And now we can rotate the shaft to find out where the keyway is. Get the gear meshed in. Secure that. Now all of these are set up with plenty of backlash. There is no need for them to be banged up tight. It will run rough if it is. And there's enough friction in the system already. Nice. Tighten that down. And now a little bit of play between them all. And now, as the feed rotates, all these gears rotate, and it rotates you can see up here, the feed rotating the dividing head. And that's basically it. Calculation of these gears, I wrote a spreadsheet to do this. It depends on the DP, number of teeth, and it's a big lookup table basically. So there we are. And here in one shot you can see the entire gear train, and the spindle of the dividing head rotates as we feed the table along.